Hi, welcome to Algebra. I'm Barb. In this video, I'm going to show you an example of how to solve a trig equation. These are really fun. You'll see that I have a quadratic type equation here. I have a sine squared, a cosine to the first, and a constant. So I want to make sure that all of my trig functions are the same across the board. So I want to make them both cosine. So since sine squared is 1 minus cosine squared, I'm going to replace sine squared with 1 minus cosine squared theta. And then everything else stays the same. And I also have this restriction here that I want my final values of theta to be between 0 and 2 pi, so around one rotation of the circle. So now I'm going to distribute the -2. I have -2 plus 2 cosine squared theta plus 3 cosine theta plus 2 equals -1. This looks much nicer because every trig function is the same. They're both cosine. So now I'm going to put everything on the left side and set the equation equal to 0. So I have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Great. Now you may have already figured out that this is a factoring problem. So this will factor as 2 cosine theta plus 1 and cosine theta plus 1. You can verify that. This is 2 cosine squared plus 1 cosine theta plus 2 cosine theta, which adds to 3 cosine theta plus 1. Awesome. So now once we have two factors that multiply to 0, we're going to set each of them equal to 0 and solve. So I have 2 cosine of theta plus 1 equals 0, and cosine of theta plus 1 equals 0. Now I'm going to solve each of these equations separately. I'll subtract 1 from both sides, divide by 2, and I have that the cosine of theta is -1/2. So then I just have to figure out where on the unit circle is cosine, or the x value, -1/2. That happens at 2 pi over 3 and 4 pi over 3. So theta is 2 pi over 3 and 4 pi over 3. So those are the values that satisfy this first equation. Now I'm going to tackle the second. Subtract 1 from both sides. And now I want to know where on the unit circle is the cosine -1. Well, that only happens here at pi, because the x value at pi is -1. So here, theta is pi. So there are 3 values within one rotation of the unit circle that satisfy this original equation, and that is theta is 2 pi over 3, 4 pi over 3, or pi. I hope this was helpful. We're turning negatives into positives. Have a great day.